Hello everyone, in basic control system theory. So this is the first lecture. In this lecture, I'll introduce basic concepts. So I shown in this slide. Okay, so let me use highlighter. So the basic difference between system and control system. Okay, so in control system, we generally represent system with block diagram. Okay, so this input and output are the signals. Okay, and this system is the mapping between the input and output. The basic difference between system and control system is that in control system we can give the desired input as input. So I have taken here one example, angle control of radio antenna. Here I have shown with manual operation. With manual operation I am doing angle control of radio antenna. So the drawbacks here are accuracy. Okay, accuracy will be less, speed will be less, consistency. Okay, the angle control of radio antenna, it should be consistent and not enough power. Since we are doing manual, not enough power. Okay, so these are the major drawbacks. Okay, if you go manual. Okay, so I have taken this example to highlight the concept of control system. Okay, in control system, input is also called stimulus and output also called response. In control system, we can give desired response as input. So this is the main difference between system and control system. This input and output are the signals. In control system, we generally represent, okay, the system which maps the input signal to output signal. Signal are UNT and YNT are represented with block diagram. Okay, this is the block diagram. Now I have taken the angle control of radio antenna, okay, with some automation. So the angle control we need to do is theta naught. So I have given, as explained here, input as desired response. So what angle we need to maintain, that have fed as input here, theta I. Potentiometer is the transducer which converts, okay, angular input into, we'll get here voltage. Okay, voltage proportional to theta I. Let me use different pen. So we'll be getting here, sorry, so here we will be getting electrical signal. Okay, here we will be getting electrical signal corresponding to theta I. The power amplifier drives the motor. Okay, this motor, okay, we make arrangement with gear arrangement. Okay, this gear arrangement in contact with this will make rotation in angle control of we find here rotation, okay, in this radio antenna system. Okay, basically what I want to explain is the angle that we want to maintain here, theta naught. Okay, that we fed as theta I, and by using potentiometer we get electric signal corresponding to theta I. Then we use power amplifier, okay, as controller. Okay, here power amplifier will act as controller. Okay, so this controller output will be fed to motor, and this motor output is in contact with this gear arrangement. In this way we can maintain the angle control. But what if suppose we want to maintain here 30 degrees and we have fed input as 30 degrees, but due to due to some external disturbance the output changes. So we need to track the output. Okay, that is what I have explained here in this diagram. In this diagram I have, here it is known as input transducer. Okay, potentiometer, this is potentiometer, input transducer that converts the theta I into electrical signal here. Here we want to maintain some angle of radio antenna system. So we will measure what's the output here using this gear arrangement. Then we use potentiometer here. Okay, this is known as output transducer, and we get an electrical signal here. This difference between the electric signals, suppose we say here 1, and here it is 2. Okay, the difference is fed to power amplifier now. In this way, the disturbance, okay, this diagram is for disturbance rejection. In this way, we can reject the disturbance, since we are not feeding here the electrical signal corresponding to theta I, but we are also including the changes that happened in theta naught due to external disturbance. And the difference we have fed to power amplifier, which act as an input to this motor, which in contact with this gear arrangement. Okay, this motor act as an actuator. Okay, so I represented here everything in block diagram. Okay, everything I represented here in block diagram. As explained here, theta I is angular input. Potentiometer, this potentiometer, okay, act as input transducer. Here we get voltage proportional to theta I. This is the theta I we have. So this is the theta I. Here we are measuring the output using some sensor. Then we use an output transducer. By using output transducer, we get voltage proportional to theta naught. Okay, this is the theta naught. We subtract this theta naught here from the theta I. Okay, electrical signal corresponding to theta naught and electrical signal corresponding to theta I. We take the difference. The difference we call it as an error. That error is fed to this controller. This controller output, we name it as U, is fed as input to this plant or process. This is the basic block diagram representation we use in control system. So I highlighted here the definition of transducer. Transducer is something that converts signal from one domain to another. So here transducer is potentiometer, which converts angle into electrical signal. Now we go to next slide. Okay, so I have taken this diagram from internet. Whatever I explained the concept, the same thing it is here. Let me move it up. As explained here, initially um, whatever angle we want to maintain here, theta naught, the theta naught is fed as theta I. Now we use here potentiometer. The potentiometer will give the electrical signal. That electrical signal is used for angle control of this radio antenna. In this diagram, I have included the disturbance. Due to some disturbance, the angle we need to maintain here will change. So we used here on another potentiometer, we sense the change in output angle, and using potentiometer here, output transducer, we get an electrical signal here. So the difference, this and this difference is used to drive the motor, which in contact with this gear arrangement. So we can visualize the previous slide, whatever I explained, we can visualize that using this picture. Finally, I have included here generic block diagram feedback control system. So the input theta I act as reference signal. Reference signal. In control system, we use reference signal, we denote with R. Output with Y. Also, output Y is called as controlled output signal. The difference. Let me use different marker. The difference, okay, we use here difference. This is the plus sign. The difference is given as error. These are the standard notations. Okay, error is fed to controller. Controller output we denote with U. These are the standard notations U, and that is given as input to this process. Process is the combination of plant and actuator. And we have disturbances. So I highlighted disturbance. Disturbance, the tacton, actuator, actuator disturbance. Disturbance, the tacton plant, plant disturbance. Disturbance, the tacton sensor, okay, measurement noise. And the reference signal R. These are known as exogenous input signal. Okay, R actuator disturbance dA, plant disturbance dP, measurement noise N. So these are known as exogenous input signal. So this is the basic introduction I would like to give regarding basic control system. So from here onwards, we can continue these lectures. Thanks for listening. Thank you.